Welcome everybody. Today we are simplifying, adding, and subtracting rational expressions. So if we have the directions say here, factor each rational expression, identify excluded values, then simplify. So we'll talk about how what that's asking us as we do one of these. All right, so number one, we first want to factor every expression we can. This is a trinomial. This is the type of factoring where we want to see, are there two numbers that multiply to this last number, which is sometimes called C, and those same two numbers have to add to this middle number, which we refer to as B, right? ax squared plus bx plus c. All right, so, well, yeah, are there two numbers that multiply to 6, add to 5? Yes, there are. That would be 2 and 3. I'll write this out the first time, but I might not do this on every problem. It'd be good to get used to not have to do this every time. It just gets a little cumbersome to write that out every time. Okay, so 3 times 2, 3 plus 2 is 5, right? Okay, so the top, then, the numerator in this fraction is going to become x plus 3 times x plus 2. In the denominator here, I also have to factor that. That one I'm not going to write out like this, but it's the same deal here. It's a trinomial. We have to find two numbers that multiply to 2 and add to 3. Well, that would be the numbers 2 and 1. Okay, so we look at this, and it did ask us to identify any excluded values. Well, if you recall, you can never have 0 in the denominator of a fraction. You can't divide by 0. It has no meaning. So our excluded values are values of x that would make the denominator 0, just the denominator. So you just kind of think of what plus 2 would be 0. Well, that'd be negative 2. So how we write out excluded values, we say, what can x not equal? Well, it can't equal negative 2, and it also can't equal negative 1. Okay? The order doesn't matter that much there, but that's how you write it out. Okay, so we've identified those excluded values. Now we simplify, and you might have seen in the directions it says cancel any common factors. So notice that we have a common factor here and a common factor here. As you recall, if you divide something by itself, they cancel out. They cancel out to 1. Okay, right? 5 divided by 5 is 1. But here we don't really have to worry about writing down that 1 because 1 times x plus 3 is just x plus 3. 1 times x plus 1 is just x plus 1. So we just leave it like this. We don't need to write the parentheses anymore because neither the numerator, the factor in the numerator, nor the factor in the denominator are multiplied by anything else. So that is our answer. And kind of along with the answer are the excluded values. So you want to sort of include that in the answer. It's just one big thing here. Okay, so that's how that works. All right, why don't you guys give your turn number 1 a shot? Okay, so what I got was x minus 4 over x minus 5, and x cannot equal 3 or 5. Now notice one thing. You might say, well, in the answer here, there's no x minus 3, so why is this an excluded value here? Well, the fact is, this problem has a history here, okay? And at some point, there was an x minus 3 in the denominator, so we do have to show that here. We do have to show that x cannot be equal to 3 in this problem. Okay, let's take a look at number 2. These are all fairly similar here. Just the factoring is a little bit different. So on number 2, the factoring, this is a difference of squares. So if you recall, we have a little formula for that if you like formulas. All right, if you have something squared minus something squared, you end up with this thing. And basically, in order to get what a is, you take the square root of a squared, right? The square root of the first thing, well, that's just going to be x for us, right? So we're going to have x here and here, right? And then b is just going to be the square root of whatever this is. You can ignore the minus. It's going to, square root of 1 is 1. So we get x minus 1 and then x plus 1. So there is this difference of squares factored. Okay, and then the denominator here, you can't factor at all. It's just that. We want to identify our excluded values, which is just going to be 1. Remember, we're just looking at the denominator. What values, if we plug them in for x, would make the denominator 0. So it's just 1. Now we can cancel out factors. It doesn't matter that there is not any parentheses around this. You can still cancel it out with the x minus 1 up there. And so you're just left with x plus 1. And then remember, keep those excluded values along with your answer. Okay? All right, you guys go ahead and do your turn number 2. All right, I got x minus 4, and then x cannot equal negative 4 because of the x plus 4 back here in the problem. All right, let's do number 3. Once again, similar process. It's just that we have slightly different type of factoring in the numerator, at least. And you should always check for this. I'm bad at reminding you guys to do this, but you should always check to see when you're factoring something, can you take out a common term? Yeah, we have 3 and 15. 3 goes into both of those numbers, right? And also they have x in common. Okay, x to the first, right? This only has an x to the first. So what we can do is rewrite the top. We can take out a 3, and we can take out an x. And then what are we left with here if we divide each of these by 3x? Well, 3x times x would give us the 3x squared. 3x times 5 would give us the 15x. And then in the denominator, this is a trinomial. 2 numbers that multiply to 15 and add to 8, well, that'd be 3 and 5. Okay. Identify those excluded values. It's going to be negative 3 and negative 5. And then we cancel out any common factors. You cannot cancel out this 3 with this 3. This 3 is involved in addition. This one's involved in multiplication. You cannot cancel those out. You can't cancel out something that's involved in addition, only in multiplication. Okay. Yeah, so it's the fact that this 3 here is involved with addition, you can't cancel it out with this one. Try that out with numbers if you're not sure, why you can do that. Do something like, 3 times 5 over 5 plus 3. Try to cancel out those 3's and actually calculate this out, see what you get. Okay, and then cancel out those 3's and see if you get the same thing. You're not going to get the same thing. Okay, so yeah, just one of those rules we got to remember. Okay, so this comes out to 3x over x plus 3. And then I have to, and that's all I can do. I can't cancel out the x's too for the same reason. This x is involved in additions, and so you cannot cancel out with that. Okay, anything involved in addition cannot be canceled out. I say that so much because it's one of the most common errors on these problems. So you've been warned. All right, so there we go. That is our answer on number 3. You guys go ahead and do your turn number 3. All right, so I get x plus 4 over 5x. X cannot equal 0 or negative 2. This is the first time we've run into an excluded value of 0. You'll notice since we had an x outside here, if you put 0 in there, 5 times 0 times whatever, you're going to get 0 in the denominator. That can't happen, so that's why that's an excluded value. It's a very similar process to finding zeros or roots when we did this in the polynomials unit. It's a very similar process. You're thinking, what values of x would make the denominator come out to 0? All right.